All right, mathematicians, we are in 8-5 Factor Bingo Game Mat, page 263. You also need to open up your student reference book to page 240 so that you can look back at the directions for this. Okay, to play Factor Bingo, it says write any of the numbers 2 through 90 on the grid above. So here's your grid. Mine's almost filled in, but you need to use these numbers 2 all the way through 90. You may use a number only once to help you keep track of the numbers you use. Circle them in the list. Well, circling was a little bit more difficult for me, so I just crossed them off. So right now I have, well, we know this is a 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We know this is a 5 by 5 grid. There's 25 spots for you to put numbers in. That means I have 24. So you know what? I'm going to make 24 my 25th number. So I crossed that off so I know I used it, and 24. So in your student reference book page, the directions say you're going to need number cards 2 through 10. So you need the cards 2, 3, 4, 5, 6, 7, 8, 9, 10. So grab a deck of cards, grab 2 through 10. If you need to look back, you're in the student reference book page, but you're going to need 4 cards for each number. So if you're using a deck of cards, if that's the number 2, you're going to need 2 black cards and 2 red cards, so you have 4 of the same number. If you do not have a deck of cards at home, you can make your own. Cut out small rectangles that are about the same size and make 4 cards that say 2, so you're going to have 2, 2, 2, 2. Then make 4 cards that have 3, so you're going to make 3, 3, 3, 3, and so on and so on. And make sure to shuffle them up really nice. And then grab out some counters. Maybe they're other colored pieces of paper, maybe they're marshmallows, maybe it's Skittles, maybe it's, I don't know, maybe it's pennies you have laying around, whatever you want to cover it up. Now it says that it's a 2 to 4 player game, but you can play by yourself or you can play with other people. And here is how. So let's say I draw the number 5 card. Oops, here we go. The number 5. Is that not going to work for me? Oh dear. Okay. Let's say I draw the number 5. Now, we're not going to pick 2 and find out a product because this is called Factor Bingo. So we want to know, what are the multiples of 5? Well, let's see. 5 times 1 would be 5. 5 times 2 would be 10. Well, let's just count by 5s because we know what that would be, right? 5 times 3 would be 15. This is just like counting by 5. So 5, 10, 15, 20, 25, and I would go all the way up until I counted all the way to 90. So do I have any factors of 5 on here? Remember, factors of 5 end with 0 or 5. Factors of 5 end with 0 or 5. Well, where should I put that? You know what? I'm going to go ahead and I'm going to do 10 because 5 times 2 equals 10. So I have my counter on my 10. Okay, let's say the next number I choose is 3. Well, what are products of 3? Because right now 3 is my factor. Well, again, I can count by 3s. 3, 6, 9, 12. Oh, goodness. Again, technology. 15, 18, oh boy, 21. And there's going to be a lot until I get all the way to 90. But I'm just going to stop at 24. Well, maybe I'll go 27. Okay, lots of them. Remember, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. That's why we have all of these products here, but it's just like adding on an extra 3. So counting by 3s. Let's see, I could do 21 here. Would that help me get a bingo? Oh, it might. You know what? 3 times 9 is 27. I could go here, which would help me get a bingo. Anywhere else? Would I put my one on my 6? Would that help me get a bingo with where my other one is? You're right, it is a product, but it's not going to help me get a bingo, but either this 21 or this 27 might. So I'm going to go ahead and I'm going to put my 27 here. So you keep flipping cards and figuring out products that are multiple of whatever you chose. until you get a bingo. And if you're against a partner, you can see who can get a bingo first. So remember, it's not always the first number that's a multiple of it, but it's the one that's going to help you get a bingo. Great. Now, once you finish this, and I want to be right here, you're going to try this one on your own, but I'll start us off. It's fraction review. So we're going to review what we know. And let's see. It says complete the problems. You may use your fraction tools. Well, let's see. I see our line is from 0 to 1. We only have one whole in here. So I want to know what's on this fraction line. Well, here's half. I know that. Okay. So halfway between 0 and half is right here. And then halfway between half and 1 is right here. So you know what? That's 1, 2, 3, 4. My whole is divided into 4 equal parts, so I know 4 is my denominator. And how many parts am I at right now? 1. I know this is 1/4. So label the point on the number line with a fraction. We just did that. You should be following along with me. Now it says write a different fraction and it names the point on the number line. I used halves to get to where I am, but there's even smaller measurements here that they have for you. So see if you can figure out another name for this point on the line. Then it says compare the two fractions you wrote using greater than, less than, or equal to. So I'm going to put 1/4 down on this side. Okay. Then you're going to take the number or the fraction, another name for this point, put it on this line, and then also in your fraction. So when you get another name for this point, and then you add greater than, less than, or equal to, what would those fractions? Would they be equivalent? Would this one be greater? Would this one be less than the new number or the new fraction? You figure that out. Number 2 says the rectangle is a whole. So we have a whole right here, one whole piece. Partition the rectangle into fourths. Shade 3/4 of the whole. Partition, remember, that sounds like part. So we're going to put this fraction into parts. And then we're going to part it into fourths. That's our key word. We know how to do that. So go ahead and make this into fourths. Then shade in 3/4 of the whole. Do that on your own. Then partition the rectangle to show eighths. So part it. So first you showed fourths. Once you're finished that, you're going to make it show eighths. Then it says how many eighths are shaded in. So put that numerator on top of that answer, how many are shaded in. And then again, take 3/4, right? Because that was our first fraction. Compare the two fractions you modeled. So we had 3/4 for our first one. Once you figure out how many is shaded over eighths, put that fraction in here. So we know 8's going to go on the bottom. And then use your greater than. That means this would be bigger. Your less than. That means this one would be smaller. Or equal to. That means these would both be equivalent. Number 3 says circle the drawings that have half of each whole shaded. So your first step might be to count how many everything is split into, and then count how many are shaded. If it's half, that number will go into equally, or it will be half of your denominator. Also look at the shapes. Are they the same sizes? Will this work? Keep that in mind. So circle the ones that have half. Does that mean there can be more than one that has half? Absolutely. So find them all. And then this one says complete the shading so 1/2 of the whole is shaded. So find out how many there is total, the denominator, and then figure out how many should be shaded in and see how many more need to be shaded in and do that yourself. And then, as always, complete math boxes on the next page. Okay, keep up the wonderful work, 3rd grade.